Hello. Now, today we are going to be looking at modulus, or absolute value, and modulus and absolute value are ideas we've actually come across before several times. It just means we're going to always take the positive version of whatever is inside our modulus signs. And where you would have come across this concept first was in coordinate geometry, when we would have been looking at the distance between A and B, point A and point B on our coordinate plane. That gave us the length or the distance between A and B, and that effectively is the same thing as modulus or absolute value. Often you'll treat modulus or absolute value a little bit differently than length, but they are logically equivalent. They are basically the same idea in a slightly different context. And if we can have that in the back of our mind, it could be helpful for some exam questions if they figure out a way to phrase things in a particular way. So modulus, very similar to the concept of length that we already know from all the way back in first year. Let's look at it in practice. If we take the simplest version of a modulus equation, we have y is equal to the modulus of x, or the absolute value of x. That means that we're always going to take the positive value of x, and that's going to be the y value. Fairly straightforward. If we look at the positive values of x, we would have when x is 0, y is 0. Straightforward. When x is 1, y is 1. When x is 2, y is 2. Everything moving very much as we'd expect. But when we come to negative numbers, we need to remember it'll always be the y value will always be taking the positive of whatever our x is. So when x is minus 1, y is 1. When x is minus 2, y is 2. So we're taking that positive value. So when x is equal to minus 1, our y would be equal to the modulus of minus 1, which would be 1. So the point minus 1, 1 would be one of the coordinates for our function. So that's how our modulus is working. We're taking the positive version of our numbers all of the time. And if we look at this in a broader context, what we will often be able to spot very quickly with our modulus is where it is touching off of, where it is striking the x-axis. So you can see in both of the graphs that I've drawn, it looks like the function is rebounding, is bouncing off of the x-axis. And where that bouncing off the x-axis happens tells us a lot about what modulus we're talking about, because it tells us where y is equal to 0, sort of like our root in our quadratics. So we're used to thinking about the roots of quadratics, and modulus is going to have a similar idea of where it touches off of, or where it bounces off of the x-axis. And we're going to figure it out the same way as we would figure out the roots of a quadratic. We would set y equal to 0 and solve our modulus. And in this case, it's very easy to visualize what's going to happen. When x is 2, we'd have 2 minus 2 would be equal to 0, and that's where our function is going to hit off of the x-axis when y is equal to 0. Other than that, we can see that we have the function rising off in both directions. We have, when x is going to be 3, we'd have y would be 3 minus 2 would be 1. So y ends up being the absolute value of 1, which is just 1. But when x is 1, we'd have 1 minus 2 would be equal to modulus of minus 1, which would also equal 1. So our function is going to have y as 1 here, and it's going to have y as 1 here. So if we were looking for, say, when x minus 2 would be equal to 1, we'd be looking for when y was equal to 1. We'd be able to use our graph and go across and say, well, that's going to happen at x is equal to 3 and x is equal to 1. And we can read that off of our graph in the same way as we'd read our quadratic or our linear graphs that we're already familiar with. So let's put this into practice in a question. We have g of x is equal to the absolute value of 2x minus 4. What I want to do very quickly is sketch this. Now the easiest way, the key pieces of information that we usually want are roots and some other point to give us an anchor for what the graph is going to look like. and our modulus is no different. So what we're going to start off with is, where is that going to be equal to 0? Where is its bouncing point going to be? So where is 2x minus 4 equal to 0? Now, our modulus means that we would always take the positive of whatever this is, but 0 is neither negative or positive, so when we're looking for the root of it, it doesn't really have much of an effect. Rearranging, we'll get 2x is equal to 4, therefore x will be equal to 2. So our function is going to hit off of the x-axis at 2. Now what else can I see about it? I can see there's a straight line, and I can see that its slope is going to be 2, because I have y is equal to 2x minus 4 if I ignore the modulus sign, so I have a slope of 2. So if I went across by 1, I'd go up by 2. And I know that this is mirrored. I know what a modulus looks like. So if I go across by 1, I'm going to go up by 2 this way as well. And if I draw in a very rough sketch, my line is going to look something like that. So that's how I can draw a rough sketch of my modulus line. I can figure out where it touches the x-axis, and then I can use the slope, or subbing in another point and seeing what values of x I get out. Both are perfectly valid ways of drawing your sketch, and you know what a modulus graph is going to look like. It's going to be coming down, bouncing off the x-axis and bouncing back the same way, or at the same angle. So we know that that's what we're looking for. So what I want to do now is ask myself a slightly different question. I'm going to ask myself, well, when is this, bit similar to what I did here, when is this function going to be equal to 2? Effectively, when is the line y equals 2 going to intersect with this line g of x, this function g of x? So when is 2x minus 4 in absolute value going to equal to 2? There's a few different ways that I can do this. First one is graphical. I'm perfectly entitled in the exam to draw a sketch, an accurate sketch, and use that to solve my problem. Full marks for that. Or I can take the fact that I know that I must always take the positive of whatever is in here. So if I know that whatever number comes here, if I ended up with this being equal to minus 2, it would still be equal to 2. If this ended up being equal to 2, and take the absolute value of it, it would be equal to 2. So if I had 2x minus 4, it could be equal to 2, or 2x minus 4 could be equal to minus 2. If I got the absolute value of either of those solutions, I would end up with positive 2, so either of those outcomes is a valid way to try and solve the problem. Rearranging here, I'd end up with 2x is equal to 6 and x is equal to 3. Or I would end up with 2x is equal to 2, x is equal to 1. So that would be a solution to my problem. And if I go to my graph, which I should have done to begin with, if I go to my graph, I'm effectively looking for the intersection points of y is equal to 2 and my function g of x, and I can see that they intersect at x is equal to 1 and x is equal to 3. So I can see my graphical method is giving me the same solution here. So I have two methods so far. I can use my graph to figure out where my y equals 2 line intersects with my absolute value or my modulus function. Or I can say that what is in my modulus sign could be positive or it could be negative. Or what modulus means that I'm going to take the positive value of something all the time. What's the other thing that I've talked about that we've learned about that means we always end up with a positive value? Squaring something. So if I have modulus of 2x minus 4 is equal to 2, I could get rid of this modulus sign by squaring both sides, because that's going to give me the positive answer regardless of whether this would work out as positive or negative. I'm going to end up with a positive answer. So when I do that out, square the first, multiply the first by the second and double it, and square the second is a fast way of squaring out a bracket. And 2 squared is 4. Now I recognize that I have a quadratic and I'm going to solve it. So I want everything on the left-hand side, and I'm going to solve my quadratic. I recognize that I have a common factor of 4 for all of my terms. I'm always looking for my common factors. Divide both sides of my equality by 4, and I end up with x squared minus 4x plus 3 is equal to 0. When I solve that, I know how to solve my quadratics. I get x minus 1 multiplied by x minus 3. Break up those answers. Either could be equal to 0 independently. So we can see here we have 3 different methods that will all work for finding the intersection of our 2 lines, or finding where an inequality is equal to a number. We can solve it graphically by looking for intersections on our graph. We can remember that because 2x minus 4, we always take the positive solution of that. It means that what's inside the modulus could be negative or it could be positive. We could have gotten minus 2 or plus 2 inside of our modulus sign, and we'd have ended up with 2 as a final answer. So both 2 and minus 2 are valid solutions, because we get the absolute value of either of them and still end up with our answer of 2 or plus 2. And finally, we remember that the other method we've got of always getting the positive solution of something is to square our numbers. So if we square both sides of our equation, we're automatically taking only the positive, which means we can ignore our modulus sign. So squaring or taking the positive or negative solution are both perfectly valid algebraic methods of finding our modulus solutions, and drawing the graph is also a perfectly valid method. All 3 will get you full marks in your exams.